Hello students, welcome to Future Doctor NEET Academy. Today I am going to solve problems in chemical equilibrium chapter. Okay, now let us see the first question in this chapter. Simple one. See the first question. In a chemical equilibrium, the rate constant for the first forward reaction is 2.5 to 10 power 2 and the equilibrium constant is 50. The rate constant for the reverse reaction they are asking. So we have one relation between, that forward reaction constant and backward reaction constant. So what's the relation means? That Kc is equal to Kf by Kr means reversible reaction constant. Understood? So here simply equilibrium constant, this is called equilibrium constant, this is called forward reaction constant, this is called reverse reaction constant. Understood? So here equilibrium constant is given, so you just substitute here 50. Understood? Which is equal to Kf, the rate constant for forward reaction, this is called forward reaction. This is also is given 2 into 10 power 2. Understood? So sorry, 2.5 into 10 power 2. Understood? By they're asking to find out only reverse reaction constant. Understood? So Kr. Okay, that's all. Simple. Okay. Now that if you rearrange, we can get therefore what? So I write it here. So therefore Kr is equal to 2.5 into 10 power 2 by 50. So this will be what? When you multiply, we'll be getting what? 250, isn't it? Okay. By 50, isn't it? Okay. So that by 50. Understood? Okay. So now you can cancel this 0, 0. So we can get answer will be what? So we can get answer will be the 5 is answer. Simple one. So if you know this formula, you can easy to solve this kind of sums. Very simple sum. Answer will be 5. Understood? Next one. For the formation of 2 moles of SO3 from SO2 and O2. 2 moles formation. 2 moles, no. So you should frame the equation 2 moles. 2 SO3. Understood? 2 moles of SO3 from what? From SO2, and O2. Then you have to balance the equation. 2 moles, no. Then only if you put 2 means this balance equation. Okay. Then this is equilibrium constant K1. So we can write, we should write the equilibrium reaction. No, we should write the equilibrium symbol. This equilibrium symbol for that. Okay, right. There is K1 is equal to what? What's K1? So product by reactant. So SO3 power 2 by SO2 power 2 into concentration of SO2. Sorry, this is K1. Understood? Next one. Say the equilibrium constant for the dissociation. See, dissociation means dissociation of what? 1 mole of SO3. Dissociation means 1 mole of SO3. No, okay. Dissociation of 1 mole of SO3. It is split into what? That SO2 plus of O2. So you must know how to frame the equation. Then only you can be able to solve the sum. Understood? Very simple. The dissociation of 1 mole of SO3 into SO2 and O2. Then for balancing equation, then I put what? Off. Okay. Then this is equilibrium constant. I consider this is called what? K2. Then outright K2 for this reason. So this is I consider it's called what? K2. Understood? Okay. Then outright product by reactant. No. So concentration of SO2 into concentration of O2 power what? 1 by 2 by concentration of SO3. Understood? So first you write the equilibrium constant value. Then you have to compare. Okay. Suppose here they are asking equilibrium constant for the dissociation of 1 mole of SO3 into SO2 and O2 is okay. So K2 is see the equilibrium. See in K1 SO3 numerator. No. In K2 SO3 denominator. Okay. Anyhow we can say K2. Okay. K2 is equal to 1 by, that will be reversed. No? Okay. SO3 numerator, here SO3 denominator. Anyhow, it will be what? K2 is equal to 1 by K1. Understood? Now, if you take the, suppose here, if you take this square root of this one, SO3 power, if you take the square root of this one means what? Square root means, or if you bring 1 by 2 means it will be cancelled. No? Okay. So if you take the square root, we will be getting that one. Okay. So then only here, we can say 1 by, understood? Okay. So K1 and K2 are opposite. Okay, they are all inversely proportional. Then only I put what? 1 by K1. But if you take the square root of this, we are getting this one. Okay, then only what's the relation between K2 and K1 means 1 by K1 the power 1 by 2. Understood? You following? Okay, right. Next one, simple one here. The equilibrium constant. They're asking to find only the equilibrium the value of Kc. So an equation is given. Simple. So an equation is given. So we have to find the equilibrium constant. So what is the Kc value? Outright Kc is equal to what? Product by reactant. No. So concentration of B power 2 into concentration of C2 by concentration of A power 2. Are you following? Understood? Just write constant. Equilibrium concentration right hand side. Product concentration by reactant concentration. So they're asking to find only Kc value. All the concentration value is given. You just substitute, then we can get answers. Simply, you know that what's the B value? B value is what? 2 into or 2 into 10 power minus 3. You know, it's a whole square, no? You put like this. Okay. Then C2, no, it's a third value, no, 1.5 into 10 power minus 4. Understood? Then concentration of A is what? Is the first value. So this also square, no? So 10 power minus 4, the whole square. Okay. Then if you simplify means, what's the answer here? You know, it's called, you know, 2 square, no? This will be, you know, it will be 4 into, understood? Then this will be what? 10 power minus 2. 10 power, sorry, minus 3 into 2, 10 power minus 6. This is what? 10 power minus 4. Then we can write here. I write it 1.5 here. Okay. Then 10 power minus 3, 10 power minus 6 minus 4 will be 10 power minus 10. Are you following? Understood? Right. Then down in denominator, who is there? 10 power minus 8 is there. Okay. Understood? Suppose here, you know, 4 into this one, 4 into 1.5, you know, we can 6. Understood? When it comes to numerator, 10 power minus 8 goes to numerator, it becomes, you know, 10 power plus 8. So 10 power minus 2. Understood? So it will be, you can write what? Let's see the option. This outright, you know, this is, we can write 0.06. Understood? This answer. Are you following? So option A is the correct one. Understood? Simply, Kc, the concentration Kc value, this is a way to find out. All the concentration, if you substitute, you can get the answer. Okay? Simple. Okay. One equation is given. What is the relation between Kp and Kc? So you know what's the formula for what's the relation between Kp and Kc? You know that Kp is equal to Kc into RT power what? Delta N G. Change in number of moles. No. Okay. Understood? Okay. Then you know you find out the delta N G. What's the formula for delta N G? What's the formula for delta N G? Delta N G means, you know, change in number of moles of gas is product minus reactant. NP minus NR. This is simply remember. Product minus, you know, reactant. Okay. So number of moles in product means what? Actually here what? You should take only gaseous substance only you should take. Understood? G. G stands for gaseous substance. Okay. So here number of moles of product, here 2, no? Here 1 plus 3. So here we have left hand side 4 moles are there. Correct or not? Right hand side 2 moles are there. So subtract 2 minus, okay, 2 minus 4, we will be getting what? Minus 2. Understood? Are you following? Okay. Minus 2. Here, simply remember, here, when it's here, now substitute here. So therefore, Kp is equal to Kc into RT power what? Minus 2. You just remember, delta Ng always negative means Kp is less than Kc. Delta Ng positive means always will be, you know, positive means Kp is greater than Kc. So delta Ng negative, you know. So you can simply remember Kp is, you know, less than Kc. Understood? Right. Okay, students. See the fourth question. You know, they're asking to find out relation between Kp and Kc. You know that this is a formula, no? Kp is equal to Kc RT per delta Ng. This is a formula to relate Kp and Kc. So delta Ng, what's the formula? Np minus Nr. This is a formula to find out, you know, delta Ng. This is a formula. Okay, just remember this formula. Okay. So Np minus Nr. You find out, you know, number of moles of product here 2, no? Number of moles of reactant is what? You know, 4. 2 minus 4, you get minus 2. So you substitute here. Simply remember, if delta Ng negative means always Kp is less than Kc. Okay. Suppose delta Ng positive means always Kp is greater than Kc. So option, you know, B is the correct one. Understood? Right. Suppose delta Ng is equal to 0 means what? Kp is equal to Kc. Understood? Are you following? Okay. Right. Next one. They are given what? Kc value is given. Kc is what? 48. Understood? Then one equation is given. In this equation, the concentration is also given. Okay. Predict the direction of the reaction. So predict the direction of reaction. How to find it means. So here first the Kc value is given. No. Now we have to find out the Qc value. Qc nothing but, you know, reaction coefficient. Okay. Right. It is applicable for non-equilibrium reaction. So it is a reaction coefficient. So you know, just like Kc, how we are writing Kc, you know, just like we can write Qc also. So product concentration by reactant concentration. So concentration of Hi, understood? The whole power 2, you know, simple. Concentration of H2, the whole power. Okay, here not whole power. Here no coefficient. No, so you simply H2 only. Then concentration of what? I2. Understood? Simple. They substitute the value. Substitute here Hi is what? Here, you know, Hi, you know, third value, you know, 0.6. 0.6. Understood? 0.6. You know, whole square. Understood? Okay. Then what is H2 value? H2 and I2 values are 0.2, 0.2. Simply you can substitute 0.2 into 0.2, 0.04. So if you multiply by, you know that multiply by 100 means we can get what? 36 by 4. 36 by 4 means, you know, answer we got 9. We just compare the value. Here, this is QC, you know, this is KC is what? KC value is somewhat higher, no? KC value is higher, but QC value is somewhat, QC is what? 9 only. Okay, this is a condition only, just remember. If, you know, here, QC is greater than KC means it's a condition. So we can say it's called reverse reaction takes place. Reverse reaction. Understood? Okay. Condition only, just remember, I write it here. If QC, okay, QC is greater than KC, okay, KC means we can say what, you know, reverse reaction takes place. Reverse, this condition, just remember, reverse reaction takes place. Okay, understood? Okay, so here QC is just quite opposite. QC is, you know, less than KC means, you know, forward reaction takes place. Forward reaction. Understood? Just remember. Okay, suppose QC is equal to KC means what? Equilibrium reaction takes place. Equilibrium. These are the conditions you should remember. You know, you can able to solve. But here in this case, whose value is higher means no, KC value is higher. KC value is higher. No, then only we can say what? Forward reaction takes place. Understood? Right. Okay. Next one. Sixth one. You know, 2NO2 gives N2O4 plus 60.0 kilojoule. Okay. Suppose here this value is positive means this is what? Endo. Just remember. This value is negative means this is called XO. So this is endo means automatically this is what? XO. Understood? Okay. Now this is equilibrium. This equilibrium, this much heat is absorbed. But again, the increase in temperature. So if you increase the temperature means what happened? They're asking. Okay. So increase in if you give some temperature to this system, what happened? Who will take the temperature means the endothermic only take the temperature. Okay. So if the endothermic reaction takes place means what? The reaction proceeds towards the forward direction. So favor the formation of what? N2O4. This is the answer. Are you following? Plus is given means this is called endo. Automatically this is XO. But we are giving some temperature. If you give some temperature among the two, XO and endo, who will take the temperature means that endo only absorbs the temperature. We give temperature. Understood? So the forward reaction takes place. So forward means what? Favor the formation of N2O4. Okay, right. Simple one. This is based on what? Lee-Chadwick principle. Understood? On equilibrium reaction is given. KC is also given. KC. Okay, right. And then the equilibrium constant for reverse reaction they're asking. Okay, reverse reaction. Suppose the forward reaction KC is given. They're asking to find only reverse reaction. So you know just you know that association equilibrium and dissociation equilibrium are inversely proportional. You know. Okay. So this is ammonia is formed. Formed means this value. Suppose ammonia is decomposed means just quite opposite. Then we can say simply can say, you know, KC dash is equal to 1 by KC. This is a formula. Just remember. Okay. Formation equilibrium and dissociation equilibrium are inversely. Formation equilibrium constant and you know, dissociation equilibrium constant are inversely proportional. Okay. Right. So that is just substitute. You know, instead of this, you substitute 1 by you know 0.5. So 0.5 means outright. 0.5 means outright. This is 1 by 2. No. 0.5 means so 2 goes to numerator. It will be got 2. Answer 2. So 2 means what? B is the correct one. Are you following? So these are the 7 questions. I said only very simple question. So based upon this, you just work out. Okay. Okay. So next class, I'll give the new lesson solutions. Thank you, students.